Ah, another kind of undercooked draft science video. Yeah. So anyway, I've been doing a little bit of work on trying to write this stuff up. So I was working on the postulates. And I'm just sort of at a point where I can't go any further until I make a commitment, to mechanism. And I'm just not sure how to draw a picture, mental picture of it, how to describe it. I'm not sure myself how, what the right description is. So I just been going through, trying to model it, and so I wanted to. Well, anyway, I did find HTML5 does let you do some things in this canvas format that's sort of like, I guess it's a poor man's version of Flash, maybe, where you can do some programming. So, this kind of nature. I mean, I suppose it must do it better than just moving divs around, because that probably gets messed up. But this seems to have a couple of artifacts in it too. But anyway, the idea will be to have this, attempt to duplicate. I'll have to, change the code, but I mean, the idea is there of what I want to do, except I want 100 of those things to bounce around and interact. So, but this sort of gives you this, just the rough idea of what an orbit is. You're just this 90-degree turn kind of idea. That if you had something in this center that had gravity, that the probability would be that more stuff would be hitting from the outside than from the inside. Stuff would get blocked by the thing having the gravity. Or if you thought of another ball just being 180 degrees inverse to this one, and the two of them would keep blocking force from the exterior. So the exterior force would have more strength, because this force would, blocking is the is the word I'm fighting with, because there's no real block. You can't really block a kinetic field. But the idea would be is you can delay it, and that's what I've been dealing with, is the idea of what constitutes speed, and how best to deal with that issue. So I kind of rewrote the first 4 postulates and took out references to the speed of light. Just because I think there's a question, that the speed of light is just a manifestation of the medium photons or quanta is traveling through, and speed is relative to that media, and space is full of these quanta, so space is a medium, essentially, what we think of as empty space. And so there's a traveling speed through that, an average traveling speed. But theoretically, there might be something more empty than space, and speeds might go even faster than the speed of light in such circumstances. As impossible as those circumstances would be to create, and it would be, I think, impossible, except in the middle of a black hole or something. But anyway, I don't want to get, well, it's always going to get messy. I'll go through some of this. The universe is made of two fundamental vast nothing in a field of indestructible, energetic quanta particles moving in straight line vectors. I don't know how to say that. I guess I could have just said moving in straight lines, something like that. Vectors might screw up the average person. In mass, these quanta produce an evenly distributed directional pressure. So obviously that doesn't say arrows going in all directions evenly, but that's the idea. So I'll draw a picture. Proportional to its mass, number of quanta, material objects can shield through absorption. So that's where it gets, I put shield in quotes, through absorption, because maybe I should have to put absorption in quotes too, because that's where it gets kind of funky. I mean, the basic idea is simple enough. That we're going from a circumstance where there's an orbit, let's just say, and it's round, so it just keeps going round. But technically there isn't an orbit, but I'll get into that. And then what happens through acceleration is that it starts doing this. And so at any one moment in time, if you just took a freeze frame of this image, this one, would look like this, but this one would look, something like this. I mean, it's got more going this way than it's got going this way. And that's the nature of acceleration, which creates velocity, which is this maintained. So when you maintain this in this shape, then you'll just keep moving once the shape is acquired. And the acquisition of the shape is merely the idea. See, this is basically, you have the same number of arrows going both ways. You have the same number going that way as you do this way. And as soon as you acquire an extra arrow going this way, well, then you have this shape instead. Well, something like that. And that shape equals this event, which ends up being velocity. But it's this whole idea of you can't really acquire it. I mean, it's just there while it's moving, so it's almost like you could say the pattern just moves through the medium. It's like all of these pixels on this screen, I could just move something through the pixels, and it's almost like just a pattern, and a pattern can move through something at the same speed the stuff would have been moving anyway. And it's not quite the right way to say it. But the trick is, with these things, is that these are all discrete little bits. So if you just get rid of the idea of orbits and just say there's locations that have gravity. So it just doesn't matter which way these things can go this way, they can go that way, they can go any way. It's just that these locations are where the gravity is, in the sense that this is where there's more arrows going this way than there is arrows going this way, because of a delay caused over here. So something blocks shields, technically. And so this is more likely to get hit by an arrow from the outside than from the inside. And that's all it's saying about this location. But this thing could be moving either way. It could be going that way, it could be going that way, it could go any way. And so technically you don't need orbits on the subnuclear level. Things don't have to be, there's no such thing as a thing with a trajectory, because everything is just these quanta, and these quanta keep going their way. So we're back to this interaction model, where two things come in and two things go out. My drawing is way out of scale there. So two things come in and two things go out, and the question is, did this happen? Did this get deflected that way and this get deflected that way, or did this go through and this go through? And the truth is the deflection is what's happening. So it's not the original thing that's going in the same exact path, but the point is that you can't really change the path. But if this interaction represents time, the creation of a moment in time, a delay, then you can understand that the more interactions you have along the way, if I have 5 interactions on this path and only 2 interactions on this path, this object will be much further forward than this one. This one will be way behind. And so then you can understand that a location would have a period of time, a magnetic moment, a moment where there wouldn't be any arrows going this way, and there would only be arrows going this way. To make things a little more complicated. But the idea is this acquisition of arrows is just such a basic idea here, is that acceleration is the collection of arrows, and velocity is the maintenance of the ones you have. So if you create an imbalance, so you go from not imbalanced to imbalanced, and then that imbalance is just maintained until some other force knocks the imbalance and knocks you back to being balanced. So you keep going in that direction until something changes that. And the real trick here is that you have to think about the systems. So electrons, neutrons, and electrons are all systems. So they all have orbits. They're all themselves complex mechanisms. And every little bit inside of them, so you can just think of them as a bunch of discrete dots. That wasn't very good, but I mean a bunch of dots, and every one of those dots has to move when it has velocity. So each one has to get a little push. It has to have an interaction. So when you start thinking about it in that sense, that you have to move everything to move this, it's just not one thing spiraling or rolling. It's every single one of these elements has to basically have its position shifted to this new position. And so that's a lot of interactions. And so you can sort of understand that if we're doing all this interacting to push all this stuff, that you have to have arrows from somewhere to do that, or there's some reason why the arrows are staying to do that. Staying, not the right word, but the point is they're falling into gravity locations, and when they do that, they're more likely to have an interaction. Something like that. I mean, even though what I just said probably didn't mean anything to you. Yeah. So again, it gets you're stuck with the trick is that although it's a kinetic field, and you have all these nice hard objects doing very simple things, what makes it complicated is that depending on what they're doing will change with the probability of you encountering an arrow going this way or an arrow going that way. I mean, there'll be changes in the disposition of the environment around you. Alright. That's an okay-ish way to say it, but I got to do better than that. But I'm just saying that obviously velocity, moving, every one of the little bits, zillions and zillions of them in my hand, every one of them, the orbit had to be changed for this velocity thing to happen. Every one of those, the neutron, the protons, the electrons, everything orbiting, everything with stuff around it, everything catching things, and anything we call a subatomic particle or entity, every one of those things had to have more interactions with an arrow going that way for it to move, without having an arrow come the other way to stop it. So it had to have more going this way than the opposite way. And yeah, that's the nature of this. So anyway, so you can maybe you can get some feel for how difficult this is I mean, it's hard to draw it on a piece of paper, and especially you're just doing 2 dimensions, and then it's 3-dimensional, which makes it even more complicated. The idea is you're also just changing, orbits that could be going this way. You give them more velocity-friendly structure if you can move them this way. And so I mean, it gets more and more complicated when you start getting into the 3-dimensional, what would they call that? It's probably that term Hoffaday told me I wasn't allowed to use. I haven't used in so long because he told me I couldn't use it. So instead of saying directional, but it's the vector or something or other. Yeah, I can't remember. It doesn't matter. Anyway. Okay. So all matter or mass is comprised entirely of still moving energetic quanta trapped in circular orbits. So again, this I'll have to change because circulars, I put orbits in bold, but I have to put it in quotes because the idea of an orbit is just probably on the subnuclear level just isn't applicable. But what you're really just saying is that you have gravitational locations, and things can get into those locations. They can go forward, they can go backward, there's just no, they can come from this direction. What fills this spot at any one time could be going in a lot of different ways, and it's not really doing this circular thing. It's only doing it in, metaphorically almost. I mean, it has the shape of it if you watched it going through its what happens to it, because it will be moved sideways, it will be knocked down, kind of, the new one will be in a new location that's usually down, and so it will end up having a shape like that. But like I said, it's going to do it in a manner that's going to be much more crazy looking. And the bottom line is, it really isn't, because it won't be one particle that's doing this. This is not really relevant, the aroundness. It's just really filling locations. So if something falls out here, it leaves, and there's an empty spot, and that empty spot theoretically is rotating, even though it's not really rotating. Well, anyway, the point is there'll be an empty spot here that something else could fill, and it would end up I'm going to say the words and it's just not right. I mean, it would end up staying, but it's not really going to stay. But the idea of it's going to stay. The spot is going to stay filled. I guess that's the point to make. There'll always be a spot, and there'll always be something in the spot. So the idea is that what matter is if the kinetic space of the universe had spacing like this, what matter's doing is creating spacing like this. So it's basically taking separated and making consolidated because of these relationships of gravitational space. And so these spots will always be full. There'll always be something in these locations, or somewhere close to that location. And that's all you're really doing, is filling a location. And so it's a consolidation of this, the chaos of the field. It's a more dense consolidation of that chaos. That's not a terrible way to say it. And it's just this, because of this probabilistic thing where when you have an interaction, when two things hit each other, this going this way and this going this way, this ends up, if this didn't happen, if this interaction didn't happen in a moment of time, okay, this thing would end up here, and in the interaction it's still going to end up forward, but it'll end up less forward because this consumed time. The interaction consumed time, which is essentially distance. And so there's less distance traveled, which means something doesn't get to something else where it would have been if that didn't happen. Okay. How else to say it? Well, anyway, the point is that this is the nature of acquisition. Is that, say something has, this pattern, the nature of the acquisition of more, of velocity or acceleration, would be the extension of, adding, separating, taking that 1 and putting 2 in here instead. And so now you have 4, going this way, theoretically, going that way. So now you have more going a certain direction. But they really don't have to be located in this left up and down. The ones going this way could be here, or they could be here, or they could be here. It doesn't matter. They just have a tendency to keep collecting arrows going in the direction of the acceleration, which in essence obliges these other elements, if they're going this, if this element's going this way, it will say this say you have 4 things. Alright, and say there's a bunch of force that's kind of coming in this way, so it's knocking these forward one notch. And let's say this one was going the exact opposite way. Well, it will leave this way, and it'll be gravitationally out of the game, and it will be replaced by one going this way. So that's the idea, is that it will be absorbed. Absorbed. Yeah, it's still not the right way to say it. I have to think of a better way to say it. Anyway, it gets very interesting when you start thinking about gravity and the idea of it being induced by velocity, or acceleration more precisely. Yeah. So that when something's accelerating, you can get the idea that when it's gaining velocity, that's when it's eating arrows the quickest. It's consuming arrows temporarily. It's storing them, and they're not getting where they would be going because they're being used to push forward all these elements. And so that's the shadow thing. That seems really obvious and intuitive. So there always has to be some sort of acceleration. And you start to look for that, though, and you say, well, where's the acceleration in the sun? Well, it sort of is in the sun with all the turbulence that's in the sun. So even though the sun is not moving, it's got all this acceleration inside of it. And there's all this acceleration that happens in the sense that it does this backward and forward thing. Which was another thing that's theoretically possible in terms of an orbit. I was thinking about it would be like an orbit that just does this. It goes back and forth, back and forth. And that's a theoretical possibility. The two things would just, they would just tilt on back and forth to each other. The thing over here would keep moving here, creating gravity here in the opposite location. So there'd always be this opposite location, but they would not go in a circle. They would just be going back and forth, back and forth. And that's a theoretical possibility. Alright, so what else do I want to say? Something about the trick with this acceleration part. Yeah, and inducing gravity. So like, you'd say, okay, I said the sun is sitting here, it's always producing gravity. So this location would always have, this is always blocking. It doesn't even matter if nothing's here, there's still gravity here, in the sense that there's going to be more arrows going this way than arrows going this way. So, but the only way that can be true is somehow the sun has to be, as if it were accelerating, it has to be absorbing them, coming from all these directions. But that's what's happening in the interior of the sun. Like I said, any big object has a tremendous amount of chemical pressure. So I mean, it's not nuclear pressure, it's chemical pressure. But I mean, it has all this acceleration, all this force coming down, and the pressure in these levels gets higher and higher in terms of the chemistry pressure, the pressure on the atoms and the molecules. So that pressure goes way up, even though there's not any nuclear pressure at that point. And then at the center, you have less nuclear pressure, so you have more tendency for the atoms themselves to start breaking down. So so I'm just saying you have a ton of opportunity for all kinds of internal accelerations inside of the object that would account for the fact that this external arrow isn't getting out here with the same regularity as it should. It's as if there's always a number of them that will be missing. So it's like, say 6 arrows go in, in a sense 6 arrows have to come out, but they're just not. I mean, that would be by crudest rule, you have to just say there's got to be 6 arrows coming out. But you know, again, if you think about it in terms of delay, the delay is also being delayed. So it's like this one's the first one that's slowed down, and then this one slowed down after that, and this one slowed down after that. So in the net, you only have 3 arrows coming out, even though you have 6 arrows going in. Because you keep accelerating something inside of the thing. And so you can produce more, you can release arrows in some other direction. So the arrows being blocked this way would end up coming out some other direction. You know, but I mean, what they're coming out is photons and heat and all this other stuff. Yeah, so I don't want to get into that, but you know, well, whatever. Yeah, I'm just saying, this is where it gets kind of gnarly. Because again, back in theory, you know what goes in. You know, you can't stop a quanton, so to speak. You just can't stop it. In theory. I mean, if I have something, it's like the photon example. But if I have something moving. Now, even if I interact with it, something hits it going this way, and this goes this way, so something's going this way still, but this thing that was going this way is now going to end up going this way, right? So this happens, right? This one got bent this way, this one got bent this way, but you still have this one. So, you know, it didn't stop. So, again, you know, you just can't get rid of it. You still have to account for it. But the accounting is in the fact that while you're accelerating, that one thing we can know for sure is that you go from, you know, having 4 of these things to having 5 of these things. So, I mean, that would be a certain, I mean, that's kind of obvious difference. That when, you know, you go from 4 to having 5, that you're, you know, they do say that with acceleration you gain a little bit of mass, so that sort of makes sense. You know, because you're acquiring this, you're either losing something in one direction or you're gaining in the other, but at any rate you're creating an imbalance in that in 2 opposite directions you have more stuff in the orbit that's going in one direction than it's going in the other direction, and that's the nature of a velocity. And yeah. Alright, what else? So I guess I wanted to go into some of the differences between, I don't know if it's worth it, but alright, well, I'll do the photon thing. Well, I'll finish this. All subatomic particles are themselves systems of orbiting quanta and not true particles. So there's no, the only thing that's a particle is the quanton, and everything else is particles trapped in relationship to each other. Quanta are trapped in a relationship. And I don't know why people are so hostile to this, because, you know, the standard model doesn't give you an explanation, you know, of the fact that there's no place that you can't just take something going the speed of light and store it somewhere called an atom or an electron. It just goes in there and just magically sits and then gets shot out at some future date back as a photon again. And that's sort of the image, and it's just, to me, that's just so unintuitive. We know these little bits are moving around really fast, and it just makes sense to say that they're still doing that. They're just doing it in an environment that consolidates them into what we call matter. So anyway, photons are a stream of 2 or more energetic quanta moving the same directional vector separated by a specific distance. So I just took out the constant speed thing just because that gets a little tricky. But I mean, the idea that photons are just quantons, and that the only thing that makes a photon different from quanta is the fact that it's a frequency, a regular frequency of pattern. Accelerating matter to any velocity requires a change in the net directional movement of the quanta that comprises it. So bolded net, because that's the important word. So when you're accelerating matter to a velocity, you're changing the arrows, and you're doing this thing. You're creating an imbalance in the direction of the velocity. All the orbits get crooked. This change of directional balance is absolute, and so your velocity is absolute. There's no such thing as relativity for velocity. Velocity is absolute. The orbits are either bent or they're not bent. There's no such thing as bent relative to the other guy. So you either have a perfect balance to the orbits of your nuclear bits, or the orbits of your nuclear bits are imbalanced, but there's no relativity. So you're either moving or you're not moving, but you're not not moving in some relative frame. No, there's only one frame. It's called reality, and everybody has to be in it. This changing of directional balance is absolute, slows down orbital atomic metabolism. So that's the one where I've tried to explain that if you're doing this sideways thing, you can't spin as fast as if you're not going sideways. So it's like dancing. If I'm dancing as fast as I can and somebody says, please dance to the right, I'll have to slow my dance down to go right. It'll use up more time. And it slows down orbital metabolism and creates the phenomenon of time dilation. So anyway, so that's as far as I got. So anyway, I was thinking about the distinctions between, the big universe and the little universe, and I just thought maybe I would think about that while I made this video. So I didn't think about it, I just thought the idea of it, and what are the differences. So the one thing that we know is there's no momentum in a real sense in the quanta. They can't break into pieces. Their velocity and mass are not things you can punch into an equation. They have one velocity and they have one mass, and there's no variability. So unlike things that the things keeping things in orbits in the big universe, we know, is their velocity, and that they're trying to escape. They're technically going in a straight line from their perspective. They have a straight line velocity, and it just keeps getting knocked out of alignment by this gravity. And the quanta really aren't doing that, because they have velocity, so they do have a direction they're going in, but they're extreme in terms of they can't be just nudged or pushed. They go radical changes in direction. And let's see, I'm trying to think of whether there's a force difference between the big and small universe in terms of if something didn't break, if we could visualize the big universe and things didn't break, like if a moon hit an Earth, there was no crushing forces or anything like that. They did just kinetically interact. And the exact amount of velocity and mass left. There was the same amount of mass going some speed in some direction. What would the implications of that be? But that hurts my brain. Yeah, so I don't think I'll get into that. The thing you have to think about is that the Earth is made up of all these, it's all these interior orbits that are essentially in. I don't want to use the word spin, because that's just going to get me back to not recognizing there's a distinction. So the big universe just can't work the way the small universe works, in the sense that it's not held together. It's still nuclear gravity. Gravity is just fooling you. the force of gravity is really this on the quanta level, and you're just seeing the way distant implications of gravity when we call it gravity on the big scale, and it's not really what it looks like. Just because this idea of what velocity is, when something's moving in an orbit, that velocity is made out of an imbalance, not a balance, where the individual quanta don't have an imbalance to start with. So it's not, they don't have a velocity. So their vector would be straight to the center, or straight, they would be, well, whatever. It's all really, I guess it wasn't a very good idea not to think about it ahead of time. Yeah, so it's just the layers, the layer on top of layer on top of layer of stuff caught in these orbits. Solar systems going around solar systems going around that solar system. And you have so many layers of this movement and so many layers of this probability changes in terms of what you're likely to encounter. And so anyway, the reason why, I'm just stuck because I have to commit to time being the thing that changes the environment. And so I'm just trying to think if it can be visualized here. Like you could sort of understand that the likelihood of hitting something when things are far apart from each other, if I send 3 things through this much distance, the number of interactions is going to be low. But if I have compressed matter, by tightly arranging it in these shapes, patterns, then my likelihood if I send 3 things in is very high that I'm going to have interactions. And so there's a high likelihood that if those interactions, if how many things you hit decides how fast you progress, then clearly something's not going to progress very fast through this versus this. And not progressing fast means you have to leave a void here for some measure of time. And if you're constantly creating a delay, so I'm just trying to get past the thing where eventually you can't dam water forever kind of idea, right? I mean, that's all you're basically saying. Okay, I can understand how you could slow something down and catch it in a dam of time for a little while, but eventually it starts overflowing the dam, and you have just this, like in a stream. If I put a dam right up a wall immediately up in front of a stream, well, for a few minutes or seconds, there's no water going downstream. But eventually the dam fills up, and then the same amount of water that was going downstream before is now going downstream, and I have a big pile of crap dammed up. I have a bunch of extra water that was going to go downstream, but it isn't going downstream anymore. It didn't go downstream for those 2 minutes. So the idea would be is that gravity is created when you're damming. Okay, so when you're building the dam or putting the dam up, now you have gravity because you have no water going downstream. But eventually that dam you built, okay, is going to say is your velocity. So say I'm moving through gravity and I'm going 5 miles an hour. And then let's just say I gained a mile an hour every second. And so then the next second I'm going 6 miles an hour, and then I'm going 7. See, if I keep gaining acceleration, well, then that means the dam just keeps getting higher. But if I stop accelerating, and then I just keep going 7 miles an hour because of wind resistance or some other bullshit, then the dam isn't being built any, it's not holding any more water, and it's now I've got a bunch of stored stuff in there, but I don't have, I'm not gaining any. So now I just have a constant rate that's back to normal. But that's what I'm fiddling with in terms of a concept. That's probably a good analogy. Maybe I'll work with that one. The idea of a dam and a stream, because it's a real good illustration of what I'm talking about. Is that there's this period, there's this moment when there's gravity, but the gravity is going to run out unless you continue to accelerate something, until you keep building the dam higher. And if you can't build the dam any higher, something's got to give, and the stuff has got to go. But that's the trick here, is that the game this is that you have to think of the dam as being some sort of slotted thing. All right, so it has many, it's more than one stream. Well, it is in a way. But let's just say, yeah, and so it's like at any one moment you'll be building the dam higher here, and at the same moment you'll be letting the dam down over here. So in two locations, one location the dam's going up, the next location the dam's going down. So you're relieving the pressure here, creating a repulsive force technically. More arrows go out because the water flies out, the extra water. And then this location, but this location's dry right in front of it because nothing's going out because the wall's going up. So if you thought about water not being able, a straight line stuff, you can kind of see that there's, a lot of water goes here, no water goes here, and then a second later, a lot of water goes here and no water goes here, and a second later, see, so it's that idea of the switching, and it's almost now I'm almost back to the two-slit experiment, in the idea that that's sort of what's happening with the two-slit experiment, except it's not migrating, obviously. I mean, you could make it migrate, just by subtly altering the slit. All of a sudden, you change what gates are open and closed. So, I mean, in that sense, it's very similar. And it's this idea that there's one that's all the way open and one that's closed. So, that's probably a good thing to, so I'll work on that. Stream, dam analogy. And again, that's why I'm really glued to this time idea, because it's about this time and the idea of delay. And that's basically what a reservoir is. Delays the water from going downstream. It keeps it here and doesn't let it go. And so you could think of a dam as if some way you could just slow the water down, it would have the same effect. If I could just turn the water into syrup, like for 100 yards. So the waters are even ice. I can make it really cold and make it move slower. So if you just thought of it like, the water moves at a regular speed, and then in this location right here, I slow it down. It would obviously build up where it just keeps coming in, where it's still hot, warm water. It would start to overflow the water I slowed down, and it would slow down, it would slow down. So, but I mean, it would just end up making this billowing, curling blob of slowness. Yeah, maybe there's some way to analogize that. Just that whole idea of something becoming a solid, going from a liquid state to becoming a solid, and how it starts to roll, and how it starts to rise and bulge and do all that. It's almost like the idea of building a reservoir. I'll have to think on that. So anyway, maybe we'll take care of a couple of comments just for the fun of it, right? I have my last video open here. Thought I did. Yeah, well, I can open it. And people aren't very helpful. Just very rude is what they are. You know, snarky assholes. So anyway, this numbly numb guy is nice enough. He posts this, you know, it's a nature site, S-Data, yeah, but actually nature.com. I mean, that's not their peer review thing, so it's not really, you know, technically it doesn't have much use to me. I mean, they have a place where you can submit for peer review, but I mean, that's the whole process and bullshit. And I'd rather just find some paid peer review. It just makes sense to me. I don't know why they just don't have paid peer review. I mean, you just pay some scientist to put their reputation on the line. What's the big deal? I'm surprised some big name scientist doesn't just say, look, I'll read anything, I'll evaluate anything for money, and I'll put my reputation on the line. So if I blow it, then you can make me look like an asshole. I mean, I think that would be perfectly reasonable. I think it should exist. So anyway, this generalist guy who I really like, well, I don't really like him, but you know what I mean. He's a nice enough guy. He's wrong about a couple of things, but you know. Well, anyway, he's kind of funny because, you know, the Mathis guy that I linked to, yeah, he has a lot of wacky theories that I think are nutty. I mean, he has some kind of, I didn't even read the articles. I said, this is just too silly. You know, but one where, you know, the ALS guy, the physicist guy, where he says, you know, he died 10 years ago and they replaced him with a fake crippled guy. I mean, it doesn't make any, I mean, what are you talking about? Why do people even bother with that kind of nonsense? So anyway, but he has this whole story about this Reed and Bryant guy and all this crap that went, I don't even know what the fuck you guys are talking about. And I'm saying, you know, who cares if a guy was in Russia, and who cares if, I don't even know why. I don't know what you're talking. I mean, it's interesting that that all you people know who all these people are, but I don't know. Gregory Zinoviev and Reed, Lewis, Bryant, Michael Dodge, blah, blah, blah. I don't know none of this shit. I don't know. I mean, I'm not terribly interested either. Just all very conspiracy, blah, 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 cloak and dagger science. It just doesn't, you know. Science is just fucked up because scientists are assholes. I mean, the whole way, I mean, I still can't believe it. You know, the Feynman debunking was never, of Lesage gravity, was a stupid, you know, it wasn't even 5 minutes. It's 2 minutes, 3 minutes of a lecture he did, you know, as a pop culture lecture, or, you know, a video lecture. You know, and they talk about this like Feynman was somehow, you know, like this is some sort of credible thing, and it was just like off the, you know, he didn't write any paper on it. He didn't do any, you know, it's nothing. It's trite. You know, and it's, you know, it has like a reputation as if he actually spent real time in analyzing it. And he didn't spend any real time. Anyway. Alright, so this guy, the universe is digital. I mean, what the fuck are you talking about? Our society is also become more and more digital, not just information, but how humans are treated. This doesn't make any sense. Digital? I mean, you know, yeah, right, wrong, okay. That's pretty digital. It's pretty binary. Yeah, see, I don't know if digital, maybe binary would be a better word to use. But I think it's just kind of I don't think you can analogize it that way, to tell you the truth. I just don't know how you can make digital out of chaos. And it's just, you know, because the universe is just all this chaos. You know, all these little quantas flying around. And yes, digital just doesn't work. It just doesn't. In a sense, it does, in the sense that there's empty space, and then there's stuff moving in the empty space. Okay, that's pretty digital. But, yeah, come on. Well, anyway, it's just stupid. It's just stupid. Oh, and there's this Nazi guy. I'll have to, when I upload this video, I'll delete this shit. Shit, man, Miles Mathis is a dramatic Jew. Go get a life, weird person. I mean, really, you silly people. Alright, so anyway, this asshole. Love it. You still claim you think the Nobel Prize is on its way. Brilliant example of extraordinary psychology. Well, again, when you're wrong, you know, I'm just going to make you eat all this stuff. You know, maybe we can find out, you know, if I do win the Nobel Prize, I'm sure we'll be able to find out who this screen name belongs to. And, yeah, I could just publicly mock you and just ridicule you as being the typical naysaying, nitpicking loser asshole who can't make a real argument. They just look at somebody's face and say, you ugly, you stupid. I mean, read book by cover. You can't do any better than that. You can't actually read a book. You can't understand a book. I mean, you lame ass. You gutless, ballless, lame ass. Make a critique that has some sort of character or shut the fuck up. I mean, god damn it. You cannot, you can't debunk, alright, even a debunker with nothing, and you have nothing. Well, not this year. It seems like lucky this year, actually something real showing that neutrinos have got mass. Well, whatever on that one. I'm not even sure they know what a fucking neutrino is. I mean, you know, to give an analogy, you know what I mean? These particle accelerators are basically just do things like scrape. It's like our solar system. It would be like separating the planets from the sun. Right? And then throwing the planets over here and throwing the sun over there. And then saying, that's a neutrino, and, you know, that's a inverted, circumcised, you know, electron. I mean, it's just bullshit. Anyway. Blah, blah, blah. You see, they don't give out Nobel Prizes for nothing. Well, again, nothing is what Einstein provided in terms of hard evidence for his everything he speculated about, okay? And the only way they even got any of it through the door, a crack in the door, was the stupid lensing part of his theory of relativity. Otherwise, no element of it has been proven. And the lensing, the gravitational lensing, is still under, it's quite reasonable to be suspect, considering how unreliable gravitational lensing seems to be as a way of measuring gravity in systems. So, fuck you. Or claiming that you've done something which you haven't done. Well, again, you're saying I haven't done it, and I'm saying, well, gee, saying I haven't done it is bullshit when I've gone to the trouble of explaining how this fits all the facts that we have collected about the nature and function of the universe. I mean, it explains inertia, which hasn't been explained by any scientist. It explains time dilation. It explains lots of shit. Red shift and blue shift and all the shifts. So, again, you're not critiquing with anything. You're just saying, I don't like what you're saying. Fuck you! Done something which you haven't done. Again, your claim. So what's your evidence that I haven't done, I haven't unified the forces, that gravity isn't nuclear? Have you heard anybody else say gravity's a nuclear force? Right? I could just go with that one alone. The very fact that I've stated gravity is a nuclear force, pretty much, you know, that's almost like E equals mc squared. It's so basic and so fundamental to accurate understanding. Do you think gravity is not a nuclear force? Do you really think that gravity is affecting big giant material things? Asshole? I mean, no one's gone to the trouble to actually imagine gravity and say, well, how small can we go where gravity disappears? And it doesn't disappear. That's the whole fucking point. And it only gets stronger and stronger as you get smaller and smaller, because it becomes the nuclear force. But anyway, oh my goodness. You're such an asshole. I haven't done a claim you've done something. It is a little more difficult actually to have done it. Well, again, how would you know? What have you done, asshole? What authority do you speak from? What difficult thing have you accomplished? What major task can we put in your accomplishment bag so you have the authority to tell other people how it is done and how much work it is? Right? You don't know how much time I have spent on this. Like I said, the last 4 years, I have spent a lot of good quality in-mendum thinking time, and in-mendum's, this quality brain thinking time. I mean, I could have been entertaining myself, and instead, I've been working on this. So don't tell me what's more difficult. Fuck you. Fuck you. You're just such a rude, obnoxious asshole. Come with a fact or shut up. What, you think I'm impressed by your fucking rude accusations of my lack of intelligence or lack of qualifications or lack of I haven't impressed you? Well, what impresses you exactly, asshole? Somebody who says having foreskin is cool? Idiot. It's a little more difficult actually to have done it. You ain't a scientist. Oh, is that it? You ain't a scientist. And the scientists are scientists? You want to name me a scientist who's, oh yeah, well let's go with that deGrasse Tyson guy. Yeah, he's a real great scientist. Pluto's not a planet. Oh, well, it only has 4 moons going around it. Great scientist. Anyway. yeah. And you'll never be. Well, again, says who? What's your qualifications? What do you know about? What scientific knowledge are you an expert in? What field of science are you an expert in? Or do you have qualification in to measure my qualifications? How much knowledge I've acquired in my life? What? What's your evidence that I lack sufficient knowledge of the subject matter I opine on, jackass? Oh yeah, that's right, you have no evidence whatsoever. I mean, you could just quote me and point out how that quote is absolutely ridiculous. That never happened. That blah, blah, blah. You could be a fact checker and actually check a fact somewhere. Check one of my statements and say, this is why it can't possibly be true and this guy's an asshole for saying it. But you're not doing that. You're fucking just being a rude, obnoxious piece of shit. And if I do win the Nobel Prize, whatever cachet that gives an individual, I'm going to request that every man with a good dick piss on you, you fucker. That every opportunity someone has to just take a piss on you, they piss on you. Because you're a piss. You deserve to be pissed on. You're a rude, obnoxious little pricky troll. And you deserve to be pissed on. Because that's all you're doing here. You're just pissing, you motherfucker. And you deserve to be pissed on. Because that's all you got to give. You little fucking weasel. Let's see. No matter how much physics envy you come up with. Well, again, I don't have any envy for people who are wrong. I mean, Einstein is frankly going to look pretty stupid. I don't envy his position. And as stated, which scientist am I supposed to admire? Exactly. Name me one. Please. Yeah, because they all aren't looking that good to me. Fuckhead. Alright, anyway. They all look pretty damn gutless. Yeah, when I do win my Nobel Prize, I'll be on the street. I'll be on YouTube still defending what I'm talking. I'm not going to hide in some ivory tower somewhere from critics. Fuckface. Fucking idiot. Anyway, so you'll get yours. Motherfucker. Trolls are they're just such a blight. So we should have a Manhattan Project. Come up with a troll irradiation device. Just to radiate fucking trolls. Yeah, as soon as you do something trollish, all of a sudden, yeah, you got a bunch of fucking radioactivity up your ass. Something like that. Anyway. The lie detector will do, yeah. So that's what we really need, is good, reliable lie detector. So they ought to have a Manhattan Project, come up with a good way to detect lies, and then we can just all face the scrutiny. You know, who's bullshitting who? You just you're the asshole with the envy problem, I think, buddy. You're a nobody, a nothing, a little fucking weaselly shit talking typer on the internet. Yeah. Yeah. I mean, you wish you had balls as big as mine. Fuckhead. Anyway, till next time. And such.